our planet faces a critical challenge, meeting our growing energy needs while preserving the environment. Traditional energy sources like fossil fuels contribute to climate change and pollute our air and water. This is why renewable energy sources like hydropower are so important. They offer a cleaner, more sustainable way to power our world. Renewable energy sources are constantly replenished by nature. Sunlight, wind, and water can all be harnessed to generate electricity without producing harmful emissions. Among these, hydropower stands out as a reliable and efficient source of clean energy. For centuries, humans have recognized the power of flowing water. From the earliest water wheels used for grinding grain to the modern hydroelectric dams that power cities, we have continuously sought to harness the energy of rivers. Today, hydropower plays a vital role in the global energy mix, providing a significant portion of the world's electricity. As we look to a future free from the constraints of fossil fuels, hydropower stands as a beacon of hope and a testament to human ingenuity. The basic principle behind hydropower is remarkably simple. Harness the potential energy stored in water held at an elevation. Picture a river cascading down a mountainside. The water possesses kinetic energy due to its motion and potential energy due to its height above a reference point. Hydropower plants capture this energy by channeling river water through a controlled pathway, typically a dam. The dam creates a large reservoir of water behind it, significantly increasing the water's potential energy. This stored water is then released through penstocks, which are large pipes that direct the water flow towards the powerhouse. As the water flows through the penstock, its potential energy is converted into kinetic energy, increasing its velocity. This high-velocity water jet then strikes the blades of a turbine, causing it to rotate rapidly. The turbine's rotational energy is then converted into electrical energy by a generator connected to the turbine shaft. A hydroelectric power station is a complex system of interconnected components working together to generate electricity from the energy of flowing water. The heart of this system lies in the powerhouse, where the conversion of mechanical energy to electrical energy takes place. Inside the powerhouse, you'll find the turbines, generators, and various control systems. The turbines are responsible for capturing the kinetic energy of the flowing water and converting it into rotational energy. Each turbine is carefully designed to operate efficiently at a specific water flow rate and head, which refers to the vertical distance between the water level in the reservoir and the turbine. Connected to the turbine shaft is the generator, responsible for converting the turbine's rotational energy into electrical energy. The generator works on the principle of electromagnetic induction, where rotating magnets within the generator induce an electrical current in stationary coils of wire. This generated electricity is then stepped up to a higher voltage by transformers before being transmitted through power lines to homes and businesses. Section 4. Turbines, the heart of hydropower. Turbines are the beating heart of any hydroelectric power station, acting as the intermediary between the raw power of flowing water and the generation of electricity. There are several types of turbines used in hydropower plants, each optimized for specific site conditions and water flow characteristics. One common type is the Francis turbine, known for its versatility and efficiency in medium-head hydropower applications. Francis turbines feature a spiral casing that directs water flow towards the turbine blades, causing them to rotate. Another type is the Pelton turbine, commonly used in high-head hydropower plants. Pelton turbines use a series of spoon-shaped buckets attached to the turbine runner. High-velocity water jets from nozzles impinge on these buckets, transferring their kinetic energy and causing the turbine to spin rapidly. The choice of turbine type depends on factors such as the head, flow rate, and power output requirements of the hydropower plant. Section 5. The crucial role of spillways. While the primary function of a hydroelectric dam is to generate electricity, it also plays a vital role in water management and flood control. Integral to this function are spillways, carefully engineered structures designed to safely release excess water from the reservoir, particularly during periods of heavy rainfall or snowmelt. Spillways act as safety valves, preventing the reservoir from overtopping and potentially damaging the dam structure. They work by providing an alternative flow path for water to bypass the turbines and powerhouse. There are various types of spillways, including overflow spillways, gated spillways, and tunnel spillways. Overflow spillways are typically located at the crest of the dam, allowing water to flow over the dam's structure when the reservoir reaches its maximum capacity. Gated spillways, on the other hand, offer greater control over the water release rate, allowing operators to adjust the flow as needed. Section 6. Hydropower, a cornerstone of sustainable energy. In an era defined by climate change and the urgent need to transition to cleaner energy sources, hydropower stands as a cornerstone of a sustainable energy future. Unlike fossil fuels, hydropower is a renewable energy source, meaning it won't run out. As long as the water cycle continues, we can harness the power of flowing water to generate electricity. Moreover, hydropower plants are highly efficient, converting a significant portion of the water's potential energy into electricity. This high efficiency translates into minimal energy losses during the energy conversion process. Unlike fossil fuel power plants that release harmful greenhouse gases, hydropower is a clean energy source, producing no air pollution or greenhouse gas emissions during operation. Hydropower plants also offer a high degree of flexibility and reliability. Operators can adjust the water flow rate through the turbines to match electricity demand, providing a valuable source of grid stability. As we strive to build a cleaner, more sustainable energy future, hydropower will undoubtedly play an increasingly important role in meeting our growing energy needs while safeguarding the health of our planet for generations to come.